It's great to see so many people here interested in testing. My name's Jonathan Gerrish, and together with my colleague Yuki Hamada, we're going to be presenting a session on testing APIs today. So just to get started, just hands up anyone who's written unit tests. It's not a trick question. Good. And what about integration tests? You can be honest. Awesome. OK, let's get started. So on Android, there's two kinds of tests you might be familiar with. There's local unit tests, and then there's instrumentation tests. So let's start by looking at local unit tests. So these are ones that these are tests that are executed on your local developer's workstation on the local VM running there. And because you don't need to run the entire Android build chain, you avoid dexing and packaging and installing on a device, these tests are actually really, really fast. On these kind of tests, you can use a tool like RoboElectric, which comes with its own set of testing APIs for setting up the state of your Android environment. Or you can use a tool like Mockito, and you can stub out the interactions with the Android framework. And either way, they allow you to write tests setting up the state of the environment that satisfy the preconditions that you might want in your test case. The second kind of tests are instrumentation tests. Now, these are the tests that will run on a virtual or a real device. A real device could just be a phone connected to your workstation, or it could be a farm of devices somewhere in the cloud. These kind of tests run slower because you have to execute the whole build chain and install an application onto the device. But they have the advantage of being a lot more accurate because the real or virtual device is very similar, or in some cases identical, to devices that your users will be using out in the field. And this brings you the confidence that your app is going to behave as you expect. One criticism we have heard is that on these kind of tests, there's actually a lack of testing APIs available, which makes it difficult for you to set up the state of your environment in a way that satisfies certain preconditions or edge cases that you might want to be testing. And so we've heard you loud and clear, and this is something we're actively working on. So a bit of a little history lesson. On 2017 at Google I/O, we presented what we call the Android testing story, so based loosely around like the software development pyramid. And in this model, we encourage you to write lots and lots of fast, scalable unit tests that test all your exhaustive conditions. We encourage you to write a smaller number of instrumentation tests that will actually prove that all these units assembled together behave as you'd expect on a real device. And in some ways, this was kind of a compromise. It was a compromise between the advantages of one kind of tests and the trade-offs of another. It sort of brings you like a holistic way of testing your app. And we showed how this kind of approach can lead to test-driven development on Android. First of all, you would start with a failing UI test. This would be an instrumentation test, probably written with Espresso, and it would test the UI of your component, your feature. And then you would satisfy that feature by a series of units, classes, coming together, their interactions. And you could test drive these as well using a tool like RoboElectric or Mockito running as a local test. And this gives you very fast development cycles. Finally, when you bring them all together, you're able to run the slower running but more faithful instrumentation test, and hopefully it goes green, and you're done. Well, we enter a refactoring cycle because maybe your code leaves a little to be desired and you want to do some cleanup. So you can spend some refactoring cycles there before coming around to the beginning of the cycle, where if you have any more work on the feature, you might add another test another aspect to that feature, and you'll keep iterating until you're complete, at which time you're good to submit your code and move on to the next task. So at Google I/O this year, we realized there was somewhat of a test writing crisis. And because there's so many tools available, it's not always clear which one to use. And each of these tools all have their own different styles and APIs and paradigms for the same concepts that exist on Android. And the problem with this is that tests written at different levels are not portable across levels. Your test is kind of stuck. It's coupled to the testing tool and the environment that you've written it on. So this year at Google I/O, we announced beta of AndroidX Test. It brings testing as a first-class citizen as part of the tool chain, as part of Jetpack. And it will include some of the existing libraries you've used before, some new APIs, full Kotlin support, which allows you to write really beautiful and concise tests, and it's available on and off device. Well, last week, AndroidX Test moved out of beta into the first full and final release, 1.0. It's also, as of last week, fully open sourced, so we look forward to welcoming your contributions. And all of the documentation on developer.android.com/training/testing has all been revamped to show you the new styles of APIs. So please go and check that out. So let's take a look inside. The first module that we pulled across was the existing JUnit 4 support, the runner and the rules that you may have used before. We've also added a new module, which we call Core, and this includes some new APIs. Application Provider, as its name suggests, it's a quick and easy way to get hold of the application context. Activity Scenario, which is a brand new API that provides coarse and fine-grained APIs for which you can test your activities. And Fragment Scenario, which was released actually just this week, providing a very similar set of testing features for fragments. We've also brought Espresso into the Jetpack AndroidX family. Espresso, if you're not aware, is a set of view matching, a library with a set of view matching APIs and a set of view actions that allow you to match and then interact with those UI elements. It also includes some other things like ability to capture and stub intents for the system. And finally, we've also released some Truth Android extensions. And Truth is Google's open source fluent testing assertions library. And we brought in a bunch of components for Android subjects, which allow you to test your Android objects in a way that reads beautifully and concisely. And those of you who've been using RoboElectric will know that we've had a version 4.0 in beta for a while. And as of last week, we did a simultaneous release that's now gone into final. RoboElectric 4 fully supports all of the unified APIs that are in AndroidX Test, as well as a number of its own new features and improvements. OK. And so I'd like to welcome Yuki on stage, who's going to give you a deeper dive into some of the APIs available. Yuki? There you go.
Thanks, Jonathan. Hi, everyone. So let me introduce our new APIs. Let's start with Application Provider, which is a new way of accessing context from your test code. Okay. So when you work on Android testing, you need to handle two different context objects. The first one is come from application. Sorry, the first one is come from application under your test. And the second one is come from the instrumentation APK, where your test code is stored. So with today's library, we have two different methods to access these context objects. And this makes your test code harder to understand because the library uses library-specific terminology. Target context means context from your instrumentation APK, while the target context means the context from your application, while get context means the context from your instrumentation APK. Also, it is not obviously which one to use for your test. So in our new API, we hide the instrumentation context from public API, and we only application provider only provides application context in the form of your application class. Let's take a look at the example code. So here, let's say we have a test for the location tracker activity, and in the setup method, we get the target context in an old-fashioned way, and we typecast it to a location tracker application, so that we can register a mock object for testing. And second line, set the mock object for that. And this code is pretty simple, and it actually works. But you could have used a wrong context and faced the runtime error and ended up with wasting your time for debugging. Now, with the new way, application context provider provides your context in your application class. So you can do exactly the same thing, but there is much less chance for confusion or bugs. OK, let me move on to the more complicated stuff, activity scenario. Actually, before we dive into details, I have a few questions for you. How many of you have written your own activity and handle the lifecycle transitions by yourself? Please raise your hand if you are. Cool. And how many of you have shipped your activity with the bugs related to lifecycles? Oh, many of you. And who didn't write a test for that? Who did not write a test? Cool. Well, yeah, I see some hands are keeping up. And to be honest, I did too. And I agree. The writing tests for the activity lifecycle transition is pretty hard. And there is no such a good API in the testing library as now. So that's why me and Jonathan and our team have sought for a solution. And we developed the activity scenario, which you can use it for driving your activity state to an arbitrary state for testing. So let's revisit the activity state first. So the created state is where an activity is created, instantiated, but it is not visible to users yet. Or activity can be created state while it is running in background as well. And the started state is where an activity is created and started. It's partially visible to users, but not the foreground activity. Activities running in picture mode is also in this state. And the rhythm state is where your activity is fully visible to users and running in foreground. And Android framework can change the lifecycle state by any time by the user interactions. So your activity has to handle those state transitions properly for a good user experience. Otherwise, you'll see some bugs. And the activity scenario provides a method, moveToState, which you can drive your activities lifecycle state to an arbitrary state for testing. Let's take a look at an example code. Here, we have a test for a location tracker activity. And here, we want to verify that location listener is properly unregistered from the system when the activity becomes created state. So at first, we have to start the activity. Launch activity takes your activity your activity class and start the activity and waits for it until it becomes resumed state. And move to state initiates the lifecycle transition and moves the lifecycle state to the created state. Also, all the activity scenario method works as a blocking call. So after this method call, it is guaranteed that the activity's lifecycle state to be created. And then you can inspect your activity's internal state by calling onActivity method. Yes, that's easy. Now we have an API. And also, you can use activity scenario for testing a recreation of your activity. So activity recreation happens when your activity is running in background for a long time and when you come back later. And your activity has to save its internal state to a saved instance state bundle before it is destroyed. Otherwise, you will lose the state. And activity scenario has a method, recreate, where you can use it for testing such a scenario. Let's see an example code. So here, in this test, we want to make sure the input text is restored properly after the activity is recreated after destruction. So first, we have some test data, like test user, as an input. And again, we start the activity. And then we we fill the text box by using the Espresso library. As you can see, the activity scenario works pretty nicely with Espresso. And then we call recreate, which actually destroys your activity and recreates the new instance and waits for the activity to be resumed state. And then, again, using the Espresso again, and we can make sure that the text is there as we expected. Yes, it's also simple. Okay, finally, I'd like to show you one more example from the truth extension. Intent subject. By use of intent subject, you can verify your intent values, and it produces really good human-friendly error messages if the error happens. Let's see an example code. In this time, we want to again make sure that we want to make sure data intent has a expected contact name in its extras. So first, we create a bundle of the data intent. And then we assert by 3 lines. One is checking if that intent has expected action. And the second one is type. And the third one is the extra bundles. And if the value doesn't match your expectation, you see this error. As you can see, like you can immediately know in this example, the intent action is not what you expected. And there are lots of components come with AndroidX Test 1.0. I can't show you everything today, but for example, like we have more assertions, and we also have Android builders where you can create your testing data easily, and also scenarios for activity and fragments. And you can take a look at this link or documentation to see more. I hope you to try it out after the talk. OK, so this is our solution for the test writing crisis. So with unified API, you no longer consider whether to write an instrumentation test or the robolectric test, because you can now just write an Android test. And that test runs on both runtime environments nicely. So with the unified API, you can focus on what to test, and you can forget about where and how. And to ensure the consistency of the behavior of our API, we have a verification test, and we run the same test against the we run the same test on locally with robolectric, and also we run our test on virtual devices. from the API level 15 to the latest version. And let's go back to the workflow we showed you earlier in this talk. So we can execute the test-driven development much more efficiently using the device agnostic test with that's the test writing in a unified API. As our recommendation, we recommend that you write the test and run the test with the Roboelectric, and then until your code is ready to submit, and then run the same test but on the virtual devices before actually you submit the test to maximize your confidence. Also, you can run the same test as a continuous integration test against the nightly built binaries. With the upcoming nitrogen tool chains, you can set up such a configuration easily. If you want to know more about the project Nitrogen, we have a session tomorrow, and we highly recommend attending it. Cool. Thank you very much for listening, and have a happy testing.